layers in this, and how that's gonna made, how exactly that architecture is gonna be an efficient architecture in order to, while it is handling the different situations and different scenarios. So HANA database is developed in C++ and runs on SUSE Linux Enterprise Server and Red Hat Linux Enterprise Server. And this database consists of index server, name server, statistic server, preprocess server, as and an access engine. So on the whole, how does it look like is those components are for HANA database. And when you look at the architecture of basic HANA Studio along with the database and along with the other connectivities, being it's a three-tier architecture, we have three layers. One is a database layer, and the other one is a presentation layer, and the other one is a reporting layer. So the database layer, we are gonna have all these name server, index server, and preprocessor server, statistic server, and all these things will come into the picture. But when you look at the presentation layer, we have HANA Studio. In that, we have in-memory computing, where it is being supported by calculation and planning engine, and we have row and column storages. I'll explain you in detail about each and every one. And the real-time replication servers are the one which will be used for the data replication from the source systems. And we have different store systems like SAP Business Suite, nothing but SAP ERP systems, SAP BW, third-party systems, and third-party can be IBM DB2, MySQL, Informatica. There are other things that are going to we can extract the data as per the client requirement. And when we talk about presentation layer, it's always about the reporting. So in the reporting, we have different kind of applications like business objects, and we can use Lumira, we can use Tableau, we can use ClickView as reporting tools. For that, each and every individual, we have different kind of connectivities. So if it is a non-SAP and if it is Microsoft, we will be using MDX kind of connectivity to get connected to the reporting layer. And if it is something like business objects, we can use SQL, and if it is business objects specific tools, we can use BIX. When we discuss about how we're going to get connected and each and every area, in depth we will discuss about this particular screen. And so now let us talk what we have in database behind the architecture. What are the servers are available, how they are allocated to each and every request, and how when a request is being processed, what are the areas it's going to touch. Suppose as I told you, we have index server, preprocessor, and name server, internal web dispatcher, access server inside this. The index server is the one which will handle any client application. In that, it holds the data and executes all operations as a whole. So, and the preprocessor server is the one which holds the unstructured data. And name server is the one which maintains landscape information. And we have a statistics server that is completely used to collect the data and about the performance of HANA server, how it is acting and how the work is being done. Do we need to allocate any kind of space for that? And if it is a regular application, reporting application like business objects, like Microsoft Office, or if it is a web analysis tool, a few other things are there. But So that is how they're going to work. So if it is application client is browser based, so the request will be processed in the form of HTTP, and the server in the database server, the internal web dispatcher will receive that request and it will hit the access server. The request, whatever is being going to processed, that will be in the form of HTTP for that. So while it is a browser-based request, internal web dispatcher server and access server will work. So now let us talk in detail about this. Is just a reporting view how it is going to work. So the nothing but the application request is nothing but the reporting request. So only if there is a reporting request, we will end up in having a data reads from the database, or else what are the data we've been receiving, what are the data we're getting from different sources is nothing but to further exclusively for the reading purpose. So what are the reports that we are going to build structurally, organizationally, the operational reports will read and hit the database. And when the database is hit by any kind of request, how each and everything is going to work, I'll show you an index server. As I told you, index server is the one which holds the data and executes all operations. So in index servers, look at the index server part here. We have persistence layer, in that data and transaction logs are monitored. I'll show you another detailed look at in this way. The session man, how the things are allocated in the index server as a database, and they're gonna how they're gonna work. So at the top of this connection we have a session management which creates and manages sessions and connections for the databases, and such as business database clients such as business objects and reporting tools or the applications. So as soon as the session is established with the database, the next step would be the transaction manager. What the transaction manager will do is it coordinates all the transactions and controls. So it allocates, in fact it will identify, okay, we received a request, so let us understand where exactly it has to go. So once the transaction manager coordinates with the transactions and it controls where it has to go, then the authorization manager will come into the picture and it says, okay, this guy is authorized. If he's a developer, yes, he can do the modifications and he can update and he can save that. And if it is a power user, okay, this guy has certain areas that he can go and fetch the data. And that is how the authorization, after authorization is done, it will get on to the request processing execution control. So what it does is, in the request processing execution, once authorization is done, what the this request processing execution control will do is the SQL statements will communicate with the request processing and execution control, and the multi-dimensional query language will act if it is an analytical application, more like what needs to be done and all these things. So the SQL script will be read and that request will be processed to the MDX thing, and the incoming SQL requests are received by the SQL processor. Data manipulation statements are executed by the SQL processor itself. So other types of requests are delegated to calculation engine and SQL parser. Oh, all these relational tables, columns, views, index, and procedures are dispatched to the metadata manager. Other things, you will understand this concept of columns, views, procedures when we see exactly the look and feel of HANA Studio. Then that kind of request, nothing but the database, whatever the schemas and the data models, whatever we're gonna develop, they are available in metadata manager, and that information can be read from metadata manager. The request, the SQL script will redirect accordingly whatever the request is being, once the authorization is done, how it has to be allocated. And if it is a row store and column store relational work, so that behind the readings can be done with the help of relational engines. So let us talk about the planning commands are routed to the, we have additional in underlying areas like a planning engine that allows financial planning applications to execute basic planning operations in the database layer. So and the SQL script is used to write the database store procedures, and procedures calls forward to the stored procedure process. So the incoming MDX requests are processed by the MDX engine and also forwarded to the calculation engine. Nothing but we will talk more about all these engines when we start talking about the models, database models. They're going to be more helpful. So underlying database has as a combination of different engines, and different engines are allocated to the different activities, and when particular engine is going to work, particular view and particular procedures are going to get executed in the system. This understanding will help us to identify the areas of the errors. If suppose we get an error, it gives an a detailed description about the error log, and based on that we can understand, okay, this is the area we have a problem, so let us go and see that. As it is a Eclipse based environment, HANA, we can see detailed information in the same window. Even you can find out the admin part. If you are authorized user, you can go out and find out, and you can reset the things accordingly. That you will understand when we see more into the look and feel. And let us talk about the persistence layer. This is the persistence layer has a high placement, like it has high availability, whatever in terms of if we have any problem in case of failure, in case of system restarts, we need to recover the data which has to be updated in the database. So in that case, the persistence layer will maintain a major part in this. So the data, it can be SQL data and undo log information, additional HANA information such as modeling data, kept in memory to ensure maximum performance is done. That is going to be done. See, when we talk about page management and logger is the one which will hold the data. And about the changes, about saved points, and the transaction, when there is a transaction committed in the database, that information will be, all kind of logs will be stored in the log management. At the same time, after backup, the overwrite information will also be stored. So this is the place from where we can retrieve the data in case of any kind of failures. And even the log volumes and the data volumes, whatever information about the data changes, and will be stored in the log volumes. And the page management, nothing but data volumes will be regular automatic save points. Like, if we try to write something into the table, that save point will be for every it's a more of internally automated process. So what it does is it will save all the data, whatever we are trying to save, whatever we are trying to pick up, all those activities information will be saved. It's a time to time base. That is how it is being design. And in that aspect, data recovery, in case of system failures, data recovery is quite easy while we are handling HANA as a database. So it consists of different phases, save points, nothing but storing the data. One, all modified pages are that will be returned to the disk. And the phase 2, the written operations are which needs to be read out in case of disaster recovery or in case of request. That kind of preparation will be done in a phase 2, and then consists of change if any updates, delta updates are there, that will be stored here. Row store information for uncommitted changes during the phases. Phase 1 will be managed in phase 2. We will have one tab where we can do that. So when we talk about particular data volumes, how we'll do backup and recovery as a part of course curriculum, then these points will be more clear to you. And then in phase 3, what will happen is the checks or checkpoints will be invoked, and the log queue will be flushed up, and the restore record is written, because again it's a more of save point point at that point. So all this is the basic architecture of persistence layer. The the important aspect in persistence layer is it's always about the backup and recovery, which are automatically rolled back after the save point is restored in case of disaster recovery. And if it is the log is replied to restore and the most recent committed state, like we lost the power, or there's something has happened in the server and we want to retrieve the data. So just few seconds back, what is happening, that information, what has happened till that time, we just can record the way it was. So that is going to save us in that way, the infrastructure for the backup servers, we need not to have spend additional in terms of client point of view. They need not to spend additional backup servers like backup server 1, backup server 2, which is going to reduce the cost for the particular infrastructure. So that is how it is going to be measured. And yeah, we were here. So that was all. That was about that particular layer in backup server. So let's talk about the index server in detail, how it worked. It's a more clear pictorial representation. Persistence layer will be there, and the data engines like SQL script, R language, calculation will be there, and the repository, nothing but the metadata repository where the request will be processed with the help of SQL MDX processors. Session manager, upper layer is the one which will establish a connection from the client applications tools to the database server. And preprocess server is the one which is going to redirect, and statistics server which will hold the data of database performance. The same thing I have mentioned very clearly. And then this MDX is nothing but it can be a ODBC connectivity or it can be a JDBC connectivity. We will establish these connections while we will make a client application available for the database. Same thing with the web-based. So web-based, if you receive any request from Lumira tools that are installed on your mobile or your PDS, then it will be read with the help of HTML, HTTP languages, and the internal web dispatcher server in the HANA system will be evoked, and the request will be in turn sent to the web-based development and administration tools. This is nothing but HANA Cloud. The regular access and HANA Cloud in turn, what it does is it will hit the HANA Studio systems, and that request will be sent out to the normal database. So again, in turn, the request processing would be how it is being accepted by the index server, but the initial authorizations will be done at the internal web dispatcher level. Thus, the whole database view, how it is working, and what are the layers that we have at different stages. So let's the same thing in more of very communicative way. the connection session will come into the authentication, and then authorization manager will send the request to the, either if it has to get on to the SQL request processor, it will go there, or if it identifies an intern, it says it is about procedures and all these things, it come to the metadata manager. Or if it is about relational stores, it will send that to the relational store, row store and column store. And then if it is about something disaster recovery, it will, or any kind of logs and any kind of save points, it will hit the persistence layer, and the relevant transactions will be done. How database? Yes, as long as it is gonna have a multi-processing structure, yes, it is a futuristic view. If it's a big client, definitely on database level, you'll get a lot of data. So for that, as I explained you in the first session, you can have a multi-core processor. You can add the processors, being it's an in-memory database. For now, it can handle almost what we can say is it's a very big database. It can handle, I just cannot let you know the number to what extent, but yes, it can meet the big clients. Like if you talk about T-Mobile, it's a day-to-day transaction. They have almost 17 billions of their records. It is still handling almost, you can take to the in TBs. It will handle a huge database. Even it is growing, all you need to do is you can extend the processors. That is, being it's an in-memory database, you can increase the processors, multi-core process, and it will support the parallel processing concept. So that is how it will support huge data, big data, to any extent. So do you still have any, you need any clarification on that point? Now it is a 1 TB on main servers. Current servers, they can handle 1 TB at the same time. So this is the whatever we have discussed till now was the basic database view, how the requests will be coming and how the things are going to send. Let us see how the data loading view, what are the areas the system is gonna work. If it is a data loading view, the request will come from the modeling, nothing but the HANA Studio. Loading means we are the one we might be working, or the request might be from an application layer. So the areas it is going to touch is views, calculation views, and all the content that belong to the modeling. And ERP agents, if it has to, being it's a real-time replication, it will hit the replication servers. If it is a non-SAP, if we have a BODS, it will hit the BODS layer. If it is an SAP system, we can have a LT replication server get invoked. And if it is other SAP sources also, we can have a BODS as a replication server. And the request, whatever the replication has been done with the help of load controller, the data will be passed on to the persistence layer at the page management. A logger will be invoked and the data volumes will be updated, and then the request process will go to the HANA database. So data loading view will cover all these areas. And the data modeling view, when we are trying to build the models from the studio, the request will be sent to the metadata manager, and if we need a data that has to be replicated, that will be, the request will be sent back to the business objects data services, and the respective operations will be processed. So these are the basic data modeling areas that we will be hitting. So the reporting view, the request will come from the client application layer, and that will be passed on to the session manager, and the same what we discussed earlier will be, all those processes will be executed one by one. So the administrator view, for an administrator, the main parts is will be HANA Studio. In that view, will be having administration and tab. It's a centralized place where you can see the server performance, database performance, and how the replications are going on. And If any table needs additional space, then and there you can adjust. If it is a huge activity, like when we are trying to replicate big tables, we can allocate the particular number of processors, and we can adjust the packet sizing. That can be done in the administration page. So that again in turn will have a connectivity with the persistence layer. So in case of, suppose when we are trying to replicate the data, in between will get cut off, and no point you starting the replication again from the scratch. We need to recover the data whatever has been read, and that connectivity has to be re-established. So what it does is it will get back to the log volumes, and in that it will try to get the data. It will try to pick up the last save point from the data volumes, and then it will in turn send that to the administration console, from where the next activity will be continued. So that kind of activities and the performance issues and load failures, everything can be monitored in the administration view. Uh, and why do we need this particular persistence layer? Does it really required at the database level? That question has been already answered in terms of database restarts, power outage. If we have to, being it's in memory, being it's a non-volatile way, we need to, it is a memory is going to be more volatile, so we need to pick up the data in a non-volatile way. For that, it is mandatory to have a persistence layer, and that technology is helping us to save the infrastructure. How I told you, like, we need not to have backup servers. In that way, the persistence layer is a very inefficient. On the whole, how it looks like is we have a studio, we have different BI tools, and we have Suite CRM, Excel systems, and the request, whenever we receive either HTTPS request, DB request in the form of SQL and MDX, SAP host agent will get activated, and that will be that once the host agent activates and the request is being processed to the internal database, how the each and every area is going to get touched, and that is shown in this particular picture. You can have a brief look which will give you the clear understanding what are the areas that it is going to hit, and how the non web-based browser things, how they're going to work, and how the web-based browser app are going to get invoked. So if it is a web-based request, direct extract connection is a one concept which will fetch the data with the help of HTTPS connectivities. And again, when it comes to the inbuilt database request processing, end of the day, all requests will land at index processor only. The same kind of activities, identification, authentication, and then SQL request processing and allocating that with the help of SQL process will be done inside of the system. And we have two scenarios in HANA database like HANA. One is it can be used as an accelerator in a sidecar scenario. Sidecar thing, there's nothing but the existing customers, they already have BW systems, so they don't want to scrap those systems. They still want to maintain the systems, and they want to, if they wish to have a HANA Studio, what they can do is they can use HANA as a sidecar. In this particular innovation, the real-time operational analytics can be done, and inbuilt accelerators will be there in that, and it will act as a primary persistence layer, and it will act as a platform, and the data will be fetched from HANA, SAP BW system. So in that way, even we can satisfy the existing customers. That is the reason most of the time they bifurcated the activities and the concept of having HANA as a database and HANA as a modeling tool in this way, like BW on HANA and HANA as a sidecar. Because in this case, HANA is going to work, sidecar, it is going to work as a modeling tool also for the real-time data replication and the real-time analytics. And if it is HANA as a database, only the database perspectives, the database activities will be performed. What are the areas that we have covered in database view, they'll be covered. We may not have a studio over there. We will definitely not have a HANA studio over there. So as a modeling tool, HANA will work in more of complicated handling, very complicated calculations, and we can fetch the full-fledged uh, benefits from the HANA Studio, having HANA as a complete package. So this is how we have two different situations, like HANA as a sidecar, BW on HANA, HANA as a total complete set of package. Hi Molly, I think you're a little
Hi.
late. Uh, so they Kapil, they'll share the data with you, this particular recording in HANA database, and how the request processing is going to be done in HANA architecture that I have explained till now. HANA is working as a database, how the HANA can be used as a data modeling. So this is the basic overview of HANA and how it is gonna work with different layers or different source systems like SAP source system, non-SAP source system, and all these things. You might get this question if you are trying to read more of information. You'll always have this question: what is this as for HANA? What is this HANA live content? HANA live content is nothing but a business content which has added more of value. In the initial releases, it's more of like customization. HANA is more of like customization. But then if it is that way, it will be very difficult for the developers to build all models, the business models in the architecture, and it will definitely not going to be, because the implementation cost will be very high for the customer. So to overlook that point, in the recent developments, they gave 100% live content, which is quite easy for the any client to replicate those data models, and those can be used. That is what that is why people are calling this as a more of automation tool. Like you have a business model in your business and you want to install that in such a way, uh, it should be just add in for the existing architecture. So you can go to HANA Live Content. It's a more it is a add-in. You can replicate those changes in the database and models. You need not, so we need not to build as a developer. We need not to stress more on that part. All we need to know is what are the underlying tables for those views, nothing but the different tables of a source system, so that we can replicate that architecture into this particular HANA Studio. And on the top of that, we can have operational reporting, which is designed by us. So the database scenarios is more like exclusively it will work as a database, and it will render the service with a BIA index inbuilt server, which will reduce the cost of maintaining BIA server as a separate entity, because BW for the performance view, most of the customers to have this indexing we have installed, most of the customers have installed BWA index. So the Trex index is inbuilt component right now, and that's gonna make it faster. In that way, it is faster. Not only the in-memory concept, in terms of hardware architectural change, we have inbuilt BIA systems that is going to help these guys to have a better speed. So the faster the access, the better the reports, the better the reports, and the faster the reports, business can take efficient decisions to improve the performance and of a business, to meet the future demand, and to meet the to allocate the budget in an efficient way based on the global economical conditions on day-to-day basis. And so that kind of operational reports can be built in a very efficient way. That is the reason people are talking about predictive analysis, people are talking about real-time data, people are talking about big data. So in order to have this big data and a very efficient on a very efficient hardware, makes a lot of sense for them to have investing in such a big database and if very costly hardware. So that is the reason most of the customers are now they're getting on to, okay, let's talk about HANA now. Let's talk about it as it came into the market in 2009. Since then, it took almost 2 and 3 years for all the partners to do a lot of research on this and give them platform. Yes, you can consider that a big data platform. That is the reason we can get the data. It's giving, like when you bifurcate this big data with the HANA, yes, it is more of like big data platform. Access applications, whatever we've been talking, is going to support that particular concept exclusively, because big data is nothing but the chunks of the data that we are getting from Google and Twitter and then Facebook, all social media is called as because you will have lots and lots of data when you compare with the regular business. So to meet that requirement, they came up with this HANA Cloud concept and Access applications, where more of Java-based work and JScript, JSON, Axon, all these technologies they have utilized to bring that data and to manipulate and put it on the requirement tools like predictive analysis, R analytics. These all are all the tools that are gonna helpful. Yes, it is big data platform. Today, do you have any questions about the architecture? Once we get on to the HANA Studio, we will understand more how these areas, what are the areas that we're going to touch one by one. And so when we are talking about different concepts, you always should think in that way. Okay, this is the area it's going to hit, so this is how the data is going to come up. Though so that analysis has to be done, that gives us a better insight to understand the areas of the issues, to convince the customer. When you're a part of any kind of client, you can convince them, and if you're building different models as a partner, uh, that gives a better understanding, and that gives a better support to explain them, hey guy, you can have this as a product, these are the best benefits of having HANA. That kind of clarification can be given. So any questions today? Molly and Venu? Okay.